Alrighty, welcome to 6.2, Finding Volume with Fractional Dimensions. So as a reminder, one big thing that we're going to need to know how to do is how to multiply fractions. And we haven't done that for a while, so I would just maybe make a big note in your notes. Remember, multiply fractions, multiply straight across. So a couple examples that we're going to do, the two on the board, if you want to jot them in your journal, I'm going to blow my notes up so you can see. So we've got 12/4 times 5/6. Remember, when we're multiplying fractions, I could multiply straight across, but I want to look to cross simplify first, just to make sure I don't have to reduce at the end. So 12 and 6 have a common factor of 6. So 12 divided by 6 is 2, 6 divided by 6 is 1. 4 and 5 do not have any common factors to shrink them down. So 2 times 5 is 10. 4 times 1 is 4, so we get 10/4. Those are both even numbers, so I know I can divide them both by 2. So 10 divided by 2 is 5, 4 divided by 2 is 2. This is an improper fraction since our numerator is greater than our denominator, so I'm going to think to myself 2 goes into 5 2 times with 1 left over. So 12/4 times 5/6 would give me 2.5. Our second example, we have 14/8 times 1/4. I'll blow my notes up again. So looking 8 and 1, we can't shrink 1 down, so there won't be any common factors, but 14 and 4 are both even numbers. So I could divide them both by 2. 4 divided by 2 would be 2. 14 divided by 2 would be 7. So my new problem would be 7/8 times 1/2. 7 times 1, since I'm multiplying straight across, would be 7. 8 times 2 would be 16. 7 is a prime number, which means I can't shrink it down anymore. So 7/16 would be my final answer. So that was just a quick refresher on multiplying fractions, because when we get to volume of fractional side lengths, our volume equals length times width times height. So if they're fractions, we need to know that process. So I kind of gave it away. What is the formula for volume? If you remember, our volume formula is length times width times height. So if we have this rectangular prism, I'll sketch it into my notes so that you're able to see me work it out in real time. Those of you that are new to my class, you're going to learn that I am just a real Bob Ross. Not really. I am not the best drawer, but you'll get the general idea. So we've got, I didn't even draw this one going the same way as the one on the screen, but we'll use the same dimensions. We've got 15 feet, 5 feet, and 5 feet. So if our formula is length times width times height, we can label length, width, and height. So to plug in, our volume would be equal to 15 times 5 times 5. And I would just solve this step by step. 15 times 5, 15 times 2 is 30, so times 4 would be 60, plus 15 more would be 75 times 5. Go ahead and work that one out. 5 times 5 would be 25. 7 times 5 is 35, plus 2 would be 37. So my volume would be 375. What would your label be on this figure? Hopefully you said cubic feet, so we have the exponent of 3 because we used 3 dimensions. So I want you to think, what would the formula be if we changed our dimensions to letters? Go ahead and try that. What do you think it would be? If I changed the dimensions of my shape to letters, so I'll draw you another beautiful rectangular prism. This one's even better than the last one. We have Q feet, K feet, and B feet. So if my formula is length times width times height, I would just plug those in. So volume is equal to Q times, so it would be a W, Q times B times K. If you did those in a different order, that's okay. Because the commutative property tells us that we can switch the order with multiplication and it'll still be the same outcome. If I changed to fractions now, what would my new formula? I just want the formula, I don't want the answer. So instead of drawing this one out, I'm just going to say my length is equal to 1/4, my width is equal to 1/2, my height is equal to 1/6. So if I plug that information into my formula, volume is equal to 1/4 times 1/2 times 1/6. So then to solve this, 1 times 1 times 1 would be 1. 4 times 2 would be 8, times 6 would give me 48. So the volume of that rectangular prism would be 1/48 cubic foot. So as long as you are aware that multiplying fractions, you multiply straight across, you should be good to go when multiplying to find the volume of a rectangular prism with fractional side lengths. Glad you made it through all the way. Thank you for doing what you're supposed to do, and I'll see you shortly for class.